Hello, everyone. This is Dr. Hui Wen, assistant professor at Indiana State University. Our major is safety management, and today I will give you a talk about how to estimate the probability that an accident never happened. Okay, this is a supplementary material for my course Safety 341, which talks about statistics and probability in safety engineering. This talk is based on a paper published on the Journal of Loss Prevention in Process Industries. Briefly, it is a literature review, and I summarize a lot of techniques how we estimate probability, how we estimate the accident probability. Since for a safety profession, every day you want to prevent the accident, especially for the major accident. So let's see what I brings to you. First, even in different cultures, we have a similar thing about the rule of three. Like in a baseball game, you can only strike three times. Then, if you fail, you are out. Or you have three times to try to succeed. If you try harder, one fail, two fail, the third time you may win. So that is the charm of three times. Similarly, in Chinese culture, also have the same thing or terminology in this way. There is a famous book in China that is called The Journey to the West. There are three disciples. They help a monk, their master, to go to the West to get some books. Okay, one day they encountered a monster, and this monster disguised herself to three people three times, one old man, one old woman, and one girl. For the disciple Sun Wukong, he identifies them very well. But for a normal human, like his master Tang Sanjiang cannot do that. So Mr. Tang was cheated by three times by this monster. Okay, so generally for a human, how they identify a monster and a human is very hard. That's also similar for accident estimation. It's very hard to identify the probability whether something may happen. Okay, so statistically, there are a lot of techniques. This is a table from my paper. It summarizes all the equations. Okay, since it's a brief talk, I will open to the public. I will not go to the details, but briefly, you need to know some general classification, like we use a frequency to estimate, or we use a Bayes estimator. Sometimes we use a logic tree, or even for now, we use a very sophisticated Bayesian networks. First, for the frequency rules, even we observed something many times and they also happen several times, we can use they happen k times divided by n observations is generally the frequency statistics. And even we go to some fuzzy estimators like the normal one, maximum likelihood estimator, or Poisson distribution, they are tended to in the similar way. And there is a general one is rule of three in statistics. If your sample is large enough, like n bigger than 30, you can, even you don't know the number of k, you can just to assign this k to 3. So for this, your probability is 3 divided by n. It covers 95% confidence interval. That is a very good estimator. Uh, so for the developing other techniques, they also use a similar terminology and go to very accuracy way. Before I go to these formulas, I won't go into that. Let's talk about some problems or tasks we need to finish. Okay, our goal is to estimate the probability. Since scenarios are unique, plans are unique, and factories are different, so sometimes a major accident usually it never happen. Can we use the 3 divided by n observation in a period of time? Sometimes we can, but it is still very big. Like an accident in nuclear plant. Oh, it should never happen. Okay, our goal is to 0, not 3. Okay, so there are some precursors before this accident happen. Precursors can be the similar accident that happened before, sometimes. Okay, and some precursors may be some general deviations or failures. Okay, so that helps us to calculate the probability. This is a sequential events happened before accident. Uh, Finally, we'll go to this way. Before it, we talk about a K accident occurred in N observation. We estimate in K divided by N or the rule of 3. Or sometimes we will talk about a 0 happens, and for that way we estimate sophisticated. So generally, let's focus on this one. If 0 happen, how we estimate? Okay, this is the third page. You see a lot of formula. I simplify those formulas. You can see this. First, you use frequency k divided by n. If you can use a more correct way, use the k bar. That means the mean or the average k in a lot of observation in different plants, different factories. Oh, if it is hard, you just use n 3 divided by n. This is a rule of 3. It's very critical, very important. Today, our main goal is to talk about rule of 3. But it is still very big in nuclear plant. We don't want that happen. In chemical plant, we don't want an explosion happen. So that is still very big. This is this probability. We go to other very sophisticated calculations, and their probability goes in this way. I changed the format of their equation. Finally, it shows similar in this way. The only difference is this part, not the denominator. It's just n. The numerator are different. Okay, and you can see it goes smaller, 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 smaller. Even it goes to 0.33 divided by n. Okay, this is for the traditional techniques we estimate accident probability. Now more we use precursor, not the occurrence of accident, and we use the sum of the precursor effect on an accident in this way, or we maximize one critical precursor, or we just go to a more general way, like a lot of precursor information and divided by n. Finally, we go to a more sophisticated as a Bayesian network. We just use some data and precursor information to calculate that. Never mind if you don't understand, you just know we are going to a very accurate way more and more. And the major accidents probability, our estimation is becomes smaller, 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 smaller. Is very small. Okay, since major accident, that's something we don't want to see. For now, you may have more questions, and we will try to solve from the equations. And we observed something from the equation, like if one precursor occurred. Precursor here will define something deviation, something bad, something negative we don't want to see, but not the major accident. That's something before the major accident. If you see one precursor, okay, there is a probability you estimate. If you see another, how does the accident probability change? Okay, this is very hard question. The second question is if m precursors occurred, how does the accident probability change? Okay, especially when the height is very big. or even when it is very small. And even for a major or critical precursor, if it occurred, after recovery, you do something to correct that, take some precautions, take some correction measurements. Okay, does that affect the probability? Very possible, but it occurs another time. It go back to the original. Does the accident probability still the same? Oh, we are not sure. Subsequently, if this critical precursor continually occurred a few times, what does the accident probability change? Okay, that's very sophisticated. Next, I'll give you some very basic equations and figures to show how it works. Okay, so if we have many precursors in this way, okay, so okay, this should be M. It should be M. Okay, sorry. We propose this equation. This is just a linear, not a linear. It's something like a log. Okay, log or exponential transform. Here we use the exponential transformed equation to define this. And we use a simple parameter. You just need to understand the conclusion. That means, if you see one precursor, the accident probability go up to this big. It's already very big. This kind of subjective probability, since that has not happened, this is not a true probability of an accident. That is, you see one something bad happened. Oh wow, you think, oh, I should be very cautious. Something may happen. That's true. If you see another bad thing happen, okay, now the situation becomes more serious. Okay, the probability go up to 88% by our equation proposed. If it happened three times, let's see the rule of three. The probability go up 95%. Wow, that's huge. That is almost one. That is very serious. Okay, so if you see some precursors, different precursors happen sequentially, one, two, three. If you see three, okay, the probability go up a lot. This is also confirms the rule of three, that which covers 95 confidence interval. A probability 95% is different with the 95% confidence interval, but it tells a similar thing. This is really high. Let's go to another way that it happens many times. Many times, what one precursor have happened many times. We go to this. Okay, also transform the for exponential. Okay, if it happened once, we estimate this is 63%. If it happened again, the same precursor happened twice. Wow, the probability also go up. Okay. If it happened three times, okay, that is also the rule of three. Even some precursor, even not the accident you observed in the history, the critical precursor occurs three times is mostly equal to the accident happens three times. This is the logic. Okay. It also goes 95%. Okay. For now, you maybe understand what I'm talking about. That is rule of three. If something have never happened, you can briefly use 3 divided by your n observation in a period to estimate the problem. But it is very big and it should go down a little. Traditionally, we go to 0.33 divided by n, but this is still very big. So we forget that we use some indicator or index or precursor. We usually say precursor to instead of those other languages. If you see precursor one, two, three, If you see 3 precursor, that is equals to C3 accident before, and your probability go up to 95%. Okay, if you just see one precursor, but it occurs 1 to 3 times, it also triggers the subjective probability of the accident to 95%. Okay, this is quite interesting. Okay, if you forgot anything what I talk about, if you don't understand this any of that, just remember rule of 3. Never let something bad happen 3 times. Okay, if you got this, okay, that is our goal today. If you have any questions, please reach me by email. Thank you. Have a great day.